Hello, my esteemed viewers. In this tutorial, we present single source shortest path problem and its solution. The problem is all about finding for a given vertex called source, finding the shortest paths to all other vertices. It's very important to realize that we are not interested here in a single shortest path that starts at the source and visits all other vertices. This would have been much more difficult problem as it is nothing other than TSP. And in fact, single source shortest path problem asks for a family of paths each leading from the source to a different vertex in the graph. Though some paths may of course have edges in common, a variety of practical applications of shortest path problem has made the problem a very popular graph algorithm of the study. Here, source may include a water tank, a silo, a bunker, a godown, a bunker holding storing cement, a silo holding grains, water tank, of course, elevated water tank meant for servicing water for the localities, and godown may contain several things. And here it amounts to resource allocation problem. It is distribution of resources to all other vertices, maybe all other cities, maybe different godowns located at different cities by connecting the source through shortest path problems. Therefore, this algorithm generates family of paths each leading from a source to different vertices or all other vertices. It is applicable to graphs with non-negative weights only, and it is also applicable for directed graph as well as undirected graph. But the graph should be, needless to say, that it should be a weighted graph, weighted connected graph. We will take an example to illustrate how exactly this Dijkstra's algorithm works. The Dijkstra's algorithm will choose the source first, and this is a very best known algorithm for this problem, and this algorithm is coming to be called Dijkstra's algorithm. This algorithm is also vertex selection based algorithm like Prim's algorithm. So here in this figure we have A as the source. It could be B or it could be D or it could be C as well as E. It depends upon the problem, and it is also context specific. And A means it may be a source holding several commodities or a single commodity which is to be distributed for all other cities. So here the algorithm starts from source, needless to say, and it finds the fringe vertices. Fringe vertices are those vertices which are directly connected to the source A. And in this example, B and D happens to be fringe vertices as far as A is concerned. From A, B has a distance of 3 units and D has the distance of 7 units. Therefore, B will be chosen. So in the first iteration, the algorithm includes B as the other vertex, maintaining a distance of 3 units from A. Now, therefore, from B, for B, C, therefore A and B is selected. This is the edge that is selected with a distance of 3 units, and as soon as B is included, the algorithm lists the fringe vertices for this B, and for this B, C and D happens to be the fringe vertices, and C has a distance of 3 plus 4 via B, okay, via B from the source. From the source, C has a distance of 3 plus 4 via B, while D has a distance of, D is also a fringe vertex for B, therefore, and D has a distance of 3 plus 2 units from the source. Therefore, D will be chosen. D will be chosen in the second instance. Now D is included. Now in the second iteration, D will also be included. Therefore, 3 vertices is already in the list. Now as far as D is concerned, C and E are the fringe vertices, and C has a distance of 3 plus 2 plus 5, that is 10 units from via D, okay, B and D. And as far as C is concerned, it maintains a distance of 3 plus 4, 7 units via B. Therefore, this is chosen. BC is chosen. Now, as far as C is concerned, the fringe vertices are D and E. D is already connected to the source, and now E is to be connected from the shortest distance. Okay, choosing the shortest distance from A, and via D, the distance happens to be 3 plus 2, 5, 5 plus 5, 10, 10 plus 6, 16. And via D, this could also be the distance 3 plus 2, 5, 5 plus 4, 9. Therefore, this is chosen. This is chosen. Now C, every other vertex is connected. Okay, B is connected via from A with AB, and D is connected from A, the source, with a distance of 3 plus 2, and E is connected with a distance of 3 plus 2, 5 plus 4, 9, and as far as C is concerned, it is connected to A, the source, 3 plus 4, that is 7 units of distance. Now, this is an example illustrating the working of the Dijkstra's algorithm for an undirected graph, and we will choose a directed graph, and we will systematically develop the algorithm. So first, A is the source over here, and it's a directed graph. As far as A is concerned, the fringe vertex happens to be D only, because D is directly connected, and in the beginning it includes A because it is the source, and A is not connected to any other vertex because that is the source. Therefore, here a blank is left, and therefore it maintains the 0 distance. As far as A is concerned, D is the fringe vertex, and D has a distance of, D is connected to A, and it has a distance of 7 units. B is not connected to A, therefore distance is infinity. C is also not connected. E is also not connected to A, therefore the distances are respectively infinity. Therefore, in the first iteration, D will be chosen. Okay, D is connected to A with a distance of 7 units. Now, D has the fringe vertices B as well as C. As far as B is concerned, it has a distance of A to D, that is 7 units, and D to B, that is 2 units. 7 plus 2, 9 units. 9 units. As far as C is concerned, it is also connected to D. From A, it maintains a distance of 7 plus 5, 12 units. And as far as E is concerned, since it is not a fringe vertex to D, therefore it is not at all connected. It still maintains an infinite distance connected to nowhere. Therefore, this is chosen. B, D, 7 plus 2 is chosen. So now A is included by the algorithm in the very first, before start of the iteration. Then D is included in the first iteration. B is included in the second iteration. Now, as far as E is concerned, C is the for C, E is the fringe vertex. For D, E is the fringe vertex. Now the E can be reached. Now these are all the C is connected to D, and E is still not connected to D, and C has a distance of 7 plus 5, that is 7 plus 5, 12 units, and it can be reached via B also. The distance then will be 7 plus 2, 9, 9 plus 2, 9 plus 4, 13. Therefore, this is more than 7 plus 5. Therefore, 7 plus 5 is to be chosen. So C is also included, and as far as C is concerned, E is the only fringe vertex, and E can be reached from A via D, okay, via DB, okay, A, D, B, C, E. As far as this path is concerned, it is 7 plus 2 plus 4, 7 plus 2, 9, 9 plus 4, 13, 13 plus 6, 19. As far as this path is concerned, it is 7 plus 5, 12, 12 plus 6 is 18. Therefore, this path is chosen. Therefore, E can be reached from A via C. Okay, it is 7 up to D, and from D to C it is 5, and C to E it is 6. 7 plus 5 plus, that is 12 plus 6, 18. 12 plus 6, 18, which is lesser than any other path. Therefore, the Dijkstra's algorithm will develop different paths from the source A for all other vertices. We will find set of paths. From A to D, it is 7 units. From A to C, it is A to D and D to B. and as far as C is concerned, it is A to D plus D to C, that is 7 plus 5, that is 12. As far as E is concerned, it is A to D, that is 7, D to C, that is 5, and plus 6. So 7 plus 5, 12, 12 plus 6, 18. So with this, we are coming to the closure of a greedy algorithm. So we discussed Floyd's algorithm, the shortest pair distance problem, and we have also discussed Prim's algorithm, that is Kruskal's algorithm, Prim's algorithm, okay, for the development of minimum spanning trees. And this is yet another problem that is solved, and this problem is called a single source shortest paths problem. With this, we will conclude greedy algorithm, bunch of algorithms developed under greedy technique, and with this we will close the session. Okay, bye.